Hello, welcome back once again. Today we're going to solve this interesting transcendental equation. 2 to the power of x plus x is equal to 12. So in this video we're going to solve for the value of x using the Newton's method. Amazing. No Lambert double function here. So let's see how we're going to solve this problem. Let us define the following function of x. F of x equals 2 raised to the power of x plus x minus 12. Now let's find its derivative. So we know f prime of x is going to be equal to 2 raised to the power of x. Its derivative will give us 2 to the power of x times the ln of 2. And then plus the derivative of x with respect to x is just 1. And here the derivative of this constant is 0. Right? Okay, that's cool. Now let us check out the following points. So let us compute f of 1, which is equal to 2 to the power of 1 plus 1 minus 12. So this is given us negative 9, which is less than 0. So f of 2 is given us 2 to the power of 2 plus 2 minus 12. So this is given us negative 6, which is less than 0. F of 3 is equal to 2 to the power of 3 plus 3 minus 12. So this is giving us negative 1, which is less than 0. So this is close to our answer, right? So here, let us compute f of 4, which is equal to 2 to the power of 4 plus 4 minus 12. So this is equal to 8, which is greater than 0. So we can see our signs change between these numbers, right? So this shows that x is less than 3. 3 is less than x and x is less than 4, right? But our solution to this problem is very close to 3. As you can see, this one here gives us negative 1, which is less than 0, okay? So now, according to Newton, x sub n plus 1 is equal to x sub of n minus f of x sub n divided by f prime of x sub n. This is our iterative formula, okay? So now, we're going to take our first starting point, letting x equals 3.1. So let's call it as x sub 0, okay? So here, we're going to let n equals 0, because if we let n equals 0, we get x sub 0 right over here. And this is its value. So here, it is going to give us x sub 1, which is equal to x sub 0 minus f of x sub 0 divided by f prime of x sub 0, which is equal to 3.1 minus. So here, this is 2 raised to the power of 3.1. plus 3.1 minus 12, then divided by f prime of x sub 0 is going to be 2 raised to the power of 3.1 times ln of 2 plus 1. Okay, so from here, x sub 1 is approximately equal to 3.146,925,5557. Interesting, right? So here, this is x sub 1. Then here, we're going to let we're going to let n equals 1. So that will give us x sub 1 here. So at the left hand side here, we're going to have x sub 1 plus 1 is 2. This is giving us x sub 1 minus f of x sub 1 divided by f prime of x sub 1, which is equal to this value. This value here, x sub 1 minus the inputs in the original function, which is 2 to the power of x plus x minus 12. So if you compute that, this one here is giving us approximately 3.146,283. And then here, this is x sub 2. Then we check for x sub 3. X sub 3 is going to be x sub 2 minus f of x sub 2 divided by f prime of x sub 2. So if you check this one out, this is giving us a repeated value of 146,283. And we can see x sub 2 and x sub 3 are the same. So if you continue, you keep getting 3.146283. So this is telling us that this is our solution, right? So from here, we can say that in the original equation, that the correct solution here is approximately equal to 3.146283. This right over here is our solution using the Newton's method. Thank you for watching. If you enjoyed the video, kindly subscribe, also like, comment, and share.